So in order to talk about the four-color process, we need to talk about Moire patterns. And I sometimes mispronounce this Moire patterns. It's an old bad habit of mine, so if I say it wrong, I apologize. It's a Moire pattern. I believe it's French. So let's take a quick look. In mathematics and physics and art, Moire patterns are large-scale interference patterns that can be produced when an opaque ruled pattern with transparent gaps is overlaid on another similar pattern. For the Moire interference pattern to appear, the two patterns must not be completely identical, but rather displaced, rotated, or have a slightly different pitch. What? Let's actually take a look at it and we'll be really quick to understand. So we're going to be talking about the four-color process with a little screen print so that we can make a kind of conceptual screen print. And by four-color, I mean we're going to talk about yellow, magenta, cyan, and black. And if you pop open your printer, you'll see that most printers have those four. Now, more expensive printers will have additional colors, and you can actually load in whatever you want in your printer, that's fine. But a standard one only needs these four to produce an insane number of colors. Now, we're not going to be using a printer, especially since we're not actually printing anything this time around, but we are going to have, the conceptual printer, the one that's, the idea is a sort of screen print. So what you'd have is a number of screens, hence I've built these kind of eye-burning squares in this checker pattern. And we're going to want to somehow overlap these so that we can get colors in a similar way that we would in an RGB system have different amounts of light coming through the red, green, and the blue in order to produce color. In this, we're going to have different amounts of cyan, magenta, yellow, and black overlaying bits and pieces of it. So this is where the Moire pattern comes into play. Notice if I just turn these on, if they're identically placed, great. We only see whatever's on the top. And we can shuffle these around and that doesn't do anything. What we've got to do is actually offset these in some way. Now you could try to do something where you just move these slightly left or right, but remember on a screen print, do you want to sit down with a ruler on this super fine, cloth and figure out if you have things offset ever so slightly? That's going to be a real pain. What's easier to do instead is to rotate things just a little bit so that they can show through. Now you see something's happening here, these weird diamond shapes. This is the Moire pattern. So let's get back to that real quick and then we can talk about the four-color process. I have 2 copies of these black squares so that I can demonstrate the Moire pattern. And remember, they're saying that it's something about being displaced or rotated in similar patterns. Well, these are identical patterns. Let's offset these. See that pattern, these different patterns that are occurring? These patterns are repeatable. In other words, you'll see the exact same pattern as I rotate things again and again and again and again. This is essentially the Moire pattern that we're going to get with these identical squares. Now you can build other kinds of Moire patterns, and if we scroll down a little bit, you can see that you can build these lines, see these diamonds, that's a Moire pattern. And you can do cool stuff like having the illusion of movement, these optical illusions when you're actually moving something. You can hide text and things inside of it. I used to have a little game as a child that would have moving and hidden objects and things with Moire pattern. Here's some overlapping circles. And if you're interested, the Wikipedia actually has a pretty solid article on Moire patterns, and it's worth reading. I check it out. It gets into the math pretty quickly, and so this is about where we're going to stop, but we're going to deal just a touch on it. Now remember I said how the pattern repeats again and again? That has to do with the angle. And for those of you that remember your trigonometry or have had it, when you start rotating, there's something called quadrants. Essentially, if you had a circle, you're only really, wow, this is burning my eyes. You're only really concerned with a quarter of the circle because it's just mirrored again and again and again. And what I mean by that, let me just make an ellipse. Wow, yeah, I know, it's a hidden layer. So if you have a circle and you were to say divide this circle up into pieces. If you had 4 of these pieces, you would have the identical circle. Now, mathematically, the mathematics of it, it's not really concerned with anything other than flipping in this 1/4. It's quadratic in nature. In other words, it's reflected around to these 3 positions. So anything you do over here within this area can be repeated within that area, within that corner, corners of a circle. Oh boy. Anyway, what I'm getting at is this. Within what we'd say 90 degrees, and a degree is just essentially a slice. If you had that circle that we were cutting up a moment ago, if you cut that into 360 equal slices, each of those slices would be a degree. So within those 90 degrees, you're going to have a crazy set of patterns. And you can see my degrees up here and also over the mouse. So with up to the first 90 degrees, you're going to get these absolutely zany patterns. But then once I hit that 90-degree point, and you'll see that it's trying to line up, but they're not perfect squares. Once I hit that 90-degree point, I'm actually going to have a repeat of the patterns that we just saw in reverse. And then those exact same patterns will occur again. And those exact same patterns will occur again and again. So really, let me set this to a 0 degree. So really, we don't have to concern ourselves with anything past that first 90 degrees, right? Because we're just going to be dealing with the same pattern. So wait, why do we have to concern ourselves at all with any of this? Let me just put this at the top real quick and hide that, turn this one off. So the Moire pattern is going to occur regardless of the color. So if we're using the 4-color process and we're doing this rotation, then we're going to start seeing these patterns. And again, you're going to want to rotate rather than offset, because rotation's easy to keep track of physically when you're dealing with your screen. And if you're offsetting, it's very, very difficult to keep track of. But these patterns are going to occur. So how do we get the least pattern? Like, what can we do to not have these patterns, if at all possible? Well, let's take a look at the math real quick. Calculator. So if everything repeats every 90 degrees because it's quadratic in nature, we have 90 degrees to work with. What we're really after is a way to show as much as possible of each of these, right? That was the initial plan. And we've got 4 to work with, but here's a little trick. Yellow is actually so light that you can do some additional tricks to it, such as using a lower line count so you get bigger dots, and then offsetting it slightly but having it at the bottom. And then you can have like this bigger blob of color, and it will be visible still, and you don't have to concern yourself as much with the Moire pattern. So let's just deal with 3. So black, cyan, and magenta. We've got 90. So let's divide out. We have 3 of them. I did that division backwards. If we've got 90 and we have 3 of them, then theoretically 30 degrees would be our points of separation. Points of separation, our furthest rotation we could get from each other, because it's just, any further and they're getting closer. It's like the old riddle, how far can you go into a forest? Halfway. Go any further and you're leaving the forest. In this case, you've got these things split up, right? So, or split up. You've got 3 of these things and you're trying to push them away from each other. You've only got 90 degrees to work with, so push them as far away from each other, but you can only go 30 degrees away, and then they start getting towards each other. So let's start with the black pattern here. I'm just going to do a transformation. And what we're going to do is something a little fun. We're going to put it at 45 degrees because remember I was talking about yellow. Talk about the solution for that. We're going to leave yellow at 0. And by leaving yellow at 0, we're just going to start, we're not going to pay attention to it, and we'll start black at 45 degrees. Do a transformation on blue. Now 45 plus 30 should be 75. And then we've got this technically, technically cyan is lighter than magenta, so I want to have the darkests on top, so we'll do this. Black at 45, magenta at 75, cyan 30 away from 75, that's going to be 105. And then we'll just leave yellow where it is. Let's take a look at this. So the argument is that this is going to be about the best pattern that we could get. So what should be happening here, and unfortunately these squares are too big for all this, this is a specific kind of Moire pattern called a rosette pattern, which let me bring up an example of it. Movie magic. Here is a rosette pattern, and you can see how it makes these little circles appearing, these beautiful little circles. That's what's referred to as a rosette pattern. There's also a dot-centered rosette pattern, which uses some slightly different angles. So if this one were, for example, made with 45, 75, and 105, since there's no yellow occurring on that, you could do a dot-centered one instead. And let me show you what that one looks like. And here is the dot-centered rosette pattern. The other one is called a clear pattern rosette, and actually that's what you get with the same degrees that we were just talking about, but then you just offset the one of the three patterns ever so slightly, and that will produce a clear to show more of the paper or cloth or what have you. With the dot-centered rosette, you use those same degrees, but you don't offset anything, and you get the dot-centered. So you see the little dot of ink in there, which we'd see on the Photoshop demonstration, except they're really packed super tightly together, so they're covering each other up, like this. And in fact, if I turn that off, you really can't tell because, well, if you pull out, you can see it a little bit. But a little bit. You can see the rosette pattern just a little bit. You can see it more with the black off. It's so dark and close together. See how it's just kind of spinning around that circle. So that rosette pattern, either the dot-centered or the clear-centered rosette pattern, is essentially as far away as these can get. So this is the Moire pattern we're probably going to be after. Now, if you're rotating things and offsetting stuff and all that, you'll need to plan all this. And in fact, if you'll remember when we were looking at the bitmap demonstration, here we go. This snail right here. Remember when we were setting it to the bitmap, we had under the halftone screen the idea of the angle. So we would be able to choose the angle here, but really that's going to need to line up with the angle of our cloth, our screen that we're rotating in order to make that work. All right, so that's essentially the rotation, but those of you who are paying like either really close attention or watching this the second time, you'll notice something. I'm in CMYK mode. I'm not in RGB mode. And in fact, if I knock this down just to the handful of patterns here, if I go to channels, you can see I have a cyan, a magenta, a yellow, and a black channel, just like the printers. Now, the question is, how do I get over here from RGB? Because, for the most part, you're working with photos and drawings and things that you've done within the computer. And you'll start by asking, is it as simple as just going to image mode and CMYK from RGB? I would not recommend doing that, actually. And let me tell you why. It has to do with your color gamut. And so we're going to revisit that and also color profiles. See you in the next video.